Yes. Because there's an overlap. There's an overlap between the two.
The pure form rather than what you're trying without vegetable.
No, it's okay. So you have time between 4:30 and 5:30 to this will not have a proper feedback session.
You need 4.
Oh, I have only one.
I have 2. Take 2.
So we got all.
Now we got all. Thank you.
You're keeping for Sunday, right?
Yes.
Yeah.
Okay, to start with, I'm going to try and put all of the mathematics related stuff we've done so far together. So Jayashree spent 2 sessions digging into proofs and getting to axioms and definitions, etc. So you start with a proof, you try digging deeper and deeper and deeper, and you get to the basic building. What I did yesterday was a session where we actually created a mathematical world. We populated it with objects, and though we didn't state axioms clearly, we didn't actually explicitly state them. We had some implicit axioms which we could dig deeper into. But our goal was to solve a problem, and in order to do that, we had to create a world. So what we're going to do now is play a game, and it's a mathematics session, but it's actually observational inquiry in mathematics. We're not going to be proving anything. I hope that makes you feel better. Okay, so.
I don't know this interaction.
Okay, can somebody just come up? Here we're going to play a game. One person. Anyone?
Tell us what to do.
So you start. You have to join one of the open ends to another open end. So open vertices. So you can connect it to here, you can connect it to here, you can connect it to there, whatever. Yeah. Yeah. And once you do that, you draw 2 new edges. Okay. And you're not allowed to go through. So I can't do this, but I can go and take it around.
It's the same problem that you stated yesterday. In a
I
different
give
way.
to
Only to us.
only to you. So just
No. The x number of lanes. Here only one intersection per line or something.
I don't know whether you'll be able to put it together. And once something is used, you can't use it again. So you can't. And you lose the game if you have no moves to make, no legitimate moves to make. You can't do that. Oh, that's already used.
Oh, okay, so I can move.
Yeah.
John, it's better to use curved lines.
John, if you can draw curved lines instead of straight ones, we'll just differentiate from the x's, the initial x's.
So this is that's used.
There's one inside. I can't go through that.
No.
Inside one.
There's one inside.
Someone there's a
There's one inside.
See how the line. Making me lose.
Yeah. Yes.
What comes next?
I was for that.
And you're done?
You know how to get out of the last minute. John is the wise guy.
What?
Yeah, I mean, you continue on these two processes.
Which use?
This, no, you cannot go through. No. This,
I don't think there's, the only open ends are 1, 2, 3, 4, 5, 6, 7, 8. And I don't think any of them have anything which they can connect. So, I win. So now I want you guys in pairs to kind of to play this game and record who starts and who wins.
That you have to be obviously inquiring.
Meaning first player, second player, winner.
And please use curved lines, except for the first two exercises.
Yeah, try and use curved lines, right? It makes it confusing if you use straight. Russell's So play it like 3, 4, 5 times. You know the game.
If you are waiting for each other, who's going to start?
One of you just quit things.
I knew this, na? You want to start.
But let's do it.
I knew.
This also is
Anything else? You're just not allowed to just try and make the lines curved. Is what I'm saying.
that you have a spoken language. Yeah, that's what I'm saying. I'm not trying to change.
While you're playing the game, could you also count the number of moves?
Maybe one you didn't count.
Next one.
It's okay.
who started amongst you?
Finish this one, then do the next one.
But this is used.
I started.
Did you start? I started.
So you start right. Whoever starts here. Is it odd if you do?
What is losing mark?
Who has no moves left?
There's no rules left.
If there are no more left, then the person who will move it now.
I have played one start. 8 moves.
You can do this. Yeah, I don't think
And when this is aligned, then you can use both the ends. When this intersection, you can use both the ends.
Yeah.
So if this end is used, I can use this.
Yeah, you can use it.
Like you what?
No. Starting with record the data, a number of moves and so on. Yeah, you have to finish this.
This is my move.
But one suppose we do the
He's always
then we start close some and then smaller number of that's it.
or even number
We try to be as fair and good as possible. Now we try to
No.
running. So that you move less number of places. But then if there are the other one.
Whoever starts will change.
So that's your so far it's holding true, whoever starts.
Yeah, but 1 second. Let's start. Let's use that.
Yeah, sure. Number of what do you do? On the intersection,
You are being good. 6.
now
7, but I won. No.
How many examples of people now?
that's all right over here.
Three? Okay, that's a good start. Let's put down the.
Last one. Nice.
Yeah, I started with 1.
Can we start with you guys give me the data? So,
Every time the person who starts
no, I want your data. How many times have you played it?
3 times.
3 times and every time the winner is the second player.
Yeah, the second player.
the second.
Number of moves have been used.
Same.
The 8 is
Huh?
both the players move, right? You count
Total number of moves.
same data.
Same. So you're getting everyone.
We have only one game in which we counted 8 moves.
But whoever
In
started
3 games, whoever started, the other person won.
Okay.
But in the last game, we counted 8 moves.
But who won that? Same.
yeah,
Same pattern.
That pattern was same.
Same.
Does anyone have an example where player one wins?
Yeah, we had.
You had an example where player one wins.
Unless I think we.
But you have to, so now you have the data. Okay, so we can.
But we don't know both are using black pen.
Huh? No. But whose move was left? Whose move is? Yes, there's clearly one move left. Okay, so the data was faulty. So anyone else?
Again, 8 moves.
No one else? Okay. So
You all have got 8 moves.
8 moves.
So this game, the first, it seems like when you start this game, the first player always loses, and there are a total of 8 moves. So now,
In fact, it is always 8
there
moves.
were 8 moves.
We had 1 6.
6. What was 6?
Oh, you had a 6 move.
Data.
Data.
Data means which one was it?
There will be 2.
You have the these two.
Yeah, these 2 moves.
Oh, we still have 2 more. Oh.
So 8 moves. So that shows it is 8 moves.
Okay, so it seems like, so if you just were told that this game was 8 moves, could you come to the conclusion that player 2 will always win? You don't know what the game is, but you know that the game is 8 moves.
Yes.
What's the argument?
That whoever finishes last is the winner. Means whoever does the last move.
Whoever does it, sure.
There's one more
So the second player,
Hmm.
and there are 8 moves, even number of moves.
Even number of moves. Yeah.
So that is divisible by the even number of the players.
So there are 2 players, and there are even number of moves. So the second player will play the last one. and
Also, we have 8 points from which we can draw one's line.
okay.
Because we have 8 points, we can.
But there are new points being added all the time.
So, but when we add a point, we are also eliminating 2 points. And we are creating 2 points, we are eliminating 2 points. So all the
So
time
the
we have
number
8
of
points.
The number of open ends.
Yeah.
is n by 2.
So the number of open ends is always 8, right?
So that means if we take 3 pairs,
How is it 8?
10,
Sorry, 1 second. 1, 2, 3, 4, 5, 6, 7, 8 here. And he gave an argument for why it always will be 8. Because you're closing 2 and you're opening 2. Yeah. So now can someone else come up? This time I'll be charitable and I'll start.
Thank you.
John is very kind.
you are not
I don't like somebody else for our side. No, I'm just saying, just to include other people.
Write the number of moves.
Somebody has tried the moves.
Go down. Down. Down, down. It's down.
No, he has to win. Starter wins if there are 3.
That's good.
Starter wins if there are 3.
Really?
But see, that's why you win zero.
This 12 is dividing and coming to the equation.
Okay,
There are 3.
so it could be either, no?
You put 3 crosses.
No, inside there, inside there. The first X. The first X inside. Yeah, yeah. Yes. Yeah. No, yeah, that's it. That one.
So you'll do one more.
No, that's it.
Yes.
No, fun.
You can play with that. Again.
13. So play like 1 or 2 games each and see if it goes.
No, I think they messed up when they counted.
13.
13.
I start because I want to win.
We can make anything.
Yeah.
He is going to open it. And let's keep move 1. Just keep doing it, huh?
I start one.
No, right.
You do that?
Try now, fresh. No, inside. Now you both try one.
This one's relatively complicated, so I think one example would be. Yeah?
That's
13.
not a win.
13 wins. Starter wins, okay.
Yeah, but we got 11 more. Maybe we did it wrong. We'll do
Starter
it.
won 13.
Okay, starter wins.
You want to put how many?
Well, it probably didn't tally, it not count.
Oh, yeah, yeah. I can't see any more than.
Yeah.
This also.
We'll do it one more. I think each one will keep it.
Starter wins. Okay. So, only if anyone gets other than 13.
Other than 13? 12. We also got 12.
Well, that means the second player wins. Yeah. Player 2 wins, not player 1. Okay. Can you show the data?
Yeah.
Not necessarily.
So here also we must have mixed it.
Anyone wants to be just a pattern down here, please? With one cross. One cross.
One cross. Acha. Second player.
So let's start.
No, 1 and 2 plus 1.
Second, the first.
First player.
Yeah, 3. This one player 1.
Even number of strikes.
Anyone wants to guess?
4 crosses.
4 crosses? Yes.
P2 and 18. P2.
And
18.
18. Anyone here?
Please 1.
On what basis are you doing this? I can guess what basis you're doing this.
5
You're adding 5 inches of pattern, okay. Can you give me a way now to find crosses? Yeah. It's P2. So this one you can give me. P2. Yeah. Yeah. Can you give me a general formula, like the type you were trying to find for that?
Like 2 n minus.
For the long moments type stuff, where you're trying to, what the formula you're trying to find. Can you find something like that over here, for the general case? 3 moves. So those guys' hypothesis is that you add 5 each time. If that's true, what is the general formula by which I can find the number of moves that you take for this?
Is that correct?
Huh?
Is that correct?
We're assuming for now. We can go back and question whether it's correct.
We have tried 1, 2, 3.
Huh?
We've tried 1, 2, 3. 4 and 5, are they correct?
4 and 5, you can give it a go.
So
3
it
into
is-
n minus 3 into 5 n minus 1.
No, 5 into n minus 2.
Same thing.
5 n minus 2.
Ah, no. So let's try that. 5n minus 2. Yeah, that seems to work. Does this make sense to?
No, but if you write it as 3 plus 5 into n minus 1, will make it easier.
Okay.
To understand. That's how I came to that. How did you come to that?
Vedish, how did you come up with that?
Move from, for every additional cross, you have to add a 5.
Okay.
The first one, you've already got a 3.
Yeah.
That's the basis.
Yeah.
So for every additional cross, you do n minus 1 into 5.
Okay. So you're for the first one it was 3, so that's 3 plus 0 times 5, and this would be 3 plus 1 times 5, and so on. Okay. And that's how you came up with the general formula. So now rather than doing x's, how about a game with y's?
With y's? No way.
Y.
No formula for that.
So what if you have just y's rather than x's?
Probably the other way around.
This is the 1, 2 over.
So try out with 2 y's and 1 y maybe or something.
2 y plus 6.
1 y is more than enough.
Is it related to the number of vertices?
Is it?
So when there were 4 vertices, 1 crosses 4 vertices, it was 3 moves.
Okay.
Then 2 crosses 8 vertices, 8. I'm just saying with the y.
So why would 4 crosses be
2 crosses.
the 1?
So if odd number, then number of open vertices minus 1.
Well, how does that work for this?
3 vertices, so 12 plus 1.
But there was minus 1.
There's minus 1, yeah. Yeah.
Because here in y there's 3 vertices and there's 2 moves when it's 1. If it's 1 y, it's 2 moves.
Okay, bye.
2 moves. If it's 2 y's, which is 6 vertices, it's 5. I'm not talking about who the winner is, I'm talking about the moves.
Okay, number what is the moves? 2.
5.
What is the
5. When it's 2 y's or 6 vertices, it's 5 moves.
Okay. Is everyone getting 5?
6 moves. 6 moves. 6. Check the data.
Data.
So this two connect with this one. This will go around this thing.
So yours is 2, 6.
Sure.
2, 6, 10, 6, 10, 14.
So any, are people getting similar things?
Yes.
Do you know who wins?
P2.
When?
What is P2?
Can you predict from the number of votes who's going to win?
Yes.
P2. Even. It's always
See,
P2.
the moves are even.
And the general formula?
2 plus 4 and minus 1.
No, everybody.
Oh, you solve it.
Yeah.
Okay. Everybody? So what the data these guys have collected seems to suggest is that 1 is 2 moves, 2 is 6 moves, and they've extrapolated from that there must be a pattern which continues. It's not great extrapolation from 2 pieces of data, but and from this you get that since it's even every time, they've got that player 2 wins every time. So given this has to be. But can someone come up with a general formula?
2 plus 4 and minus 1.
So they're using the same technique that this is 2 plus 4 times 0, this is 2 plus 4 times 1, this is 2 plus 4 times 2 and so on. So the general formula here seems to be 2 plus 4 times n minus 1. Huh? Does anyone predict what it would be for a 5?
5 and minus 2.
So for 3 Ys, how much do you take?
So what we've got now So this seems to be the pattern. Okay, so now within that pattern, can you see another pattern?
N minus 1 plus n 2 n minus 1.
Right. So first, what would it be for this?
4 plus
6 and
6
And now for the
5 plus
7
7.
plus 7.
can someone give me for m sided
n minus 2.
M plus
n plus
2. M plus n plus 2.
m plus
M plus
n plus 2
M plus.
So here m is 3.
No, M minus 1.
M minus 1.
M minus 1.
M minus 1.
Ah, okay.
n minus 1 plus
Plus M plus 1.
Yeah.
Plus
M plus 1.
Into n minus.
Into n minus 1.
So you got your general formula for an m sided n number of m-sided figures. But what will happen? So now, how would you judge who would win with an m-sided?
For even number of moves, it will be P2 always.
No, but in the M thing.
And for odd number of moves, it is P1 always.
No, but
Oh, sorry.
in this case, P2 always won. For the Ys, P2 always won.
Yes. So that's even number of moves that ended the game.
No, this is even number of moves.
Yes.
So how do you know whether there are even number of moves?
So you calculate the number of moves at the end.
No, so now you need to tell me
With the variable.
for a given m, how would you tell me what the number of moves? What the number? Who will win? Who will win with an odd number of objects and with an even number of objects? So now, how you would go about doing that is assuming that one m is odd and m is even. That's what seems to be the difference.
Yeah.
So if you look at this one will always be
Open ends.
right because you can take two out. Here, this one will always could be odd, could be even, depending on what n is. And once again, this one will always be even. Does everyone see why that is?
Yeah, because you can take the even number as a common factor.
So this can be 2 times 1 plus
1
2
plus 2 and 1.
and minus 1. And this can be 2 times 2 plus, so this. And an even number is a number which is divisible by 2, and clearly this is divisible by 2. So you would say that if m is, so can you come with the general statement on who will win?
If m is odd, the number of moves is always even, and hence P1 wins.
Okay, so if m is odd, you mean P2 only?
Yeah.
P2.
Yeah.
P2 will be.
P2.
No, Vignesh?
Using clay.
P2 is always
The
even.
first game, the first.
No, by if there are even number of moves, who will play the last move?
P2.
So
So
P1
P1 will win.
No,
No,
P1
P2
will
will
lose.
win.
P1 will lose.
Okay.
P2.
Yeah.
We didn't know the number of pairs.
It was not P2 is always.
Mother, we have this part of code and then write.
Okay, let's see how it comes in.
Then it's all.
So if M is odd, number of moves is even.
M is odd and N is even, M is odd.
What happens here?
Here it's alternates.
So what? If m is odd,
And,
N is even.
so if n is even,
P1.
P1.
N is even P.
does everyone see why that's happening?
N is number of moves. Huh?
N is
No, N is number of frames.
crosses.
Number of crosses. Number.
P2 always win? Okay, this and this we seem to have got some sort of closure on this part at least. So now, I think, yeah, I might end early, but there's lots left to problem. What about mixtures of these shapes? So if you have a y and an x, or a y and a 5-sided thing, or 7 y's and 3 whatever, who will win in each of those cases and what will be the total number of moves. That's the rest which I'm going to leave for you and end this early.
Are we going to prove it?
The main part which is left is you guys haven't proved any. Apart from you proved that if this is even P2 wins, I'm happy with that. But you haven't shown that these number of moves will always happen in any version of this game. We've only had a sample of games. So you've basically been doing observational inquiry and coming up with a generalization, and not very high quality observational inquiry because we've been taking like 2-3 examples and not doing like, we would ideally want to take a large sample and to make a conclusion. But however, if we want to we want to show that this happens every time, and I think all of us think that this would happen in any game. At least some of the ones we've tried, that this is 6 and this is 8 for 2 x's and so on. To prove that, now you'll have to appeal to constructing definitions and axioms, etc., and coming from there to a proof, which is outside the realm of today. But you can work on that. Okay. Thank you. Any questions?
So again, the proof would go by like what you said is say mathematical induction. This is mathematical.
No. This is inductive reasoning. This is outside of.
Then what is mathematical induction?
Mathematical induction is a very, very different thing. It is. Jesse, what's a good example? Simple.
You find the sum of first 10 integers.
Okay.
Right now.
I think this was actually a part of one of the learning triggers, but I don't think the proof was. The sum of the first n integers is n times n minus 1 over 2.
N plus 1.
N times n plus 1? So the first one integer will be 2. Yeah. So sum of the first n integers is this one. Now how we want to prove it is the sum of the first one integer is what? 1. And that fits. Right? If you plug in 1 here, that fits. That's called the base case. I'm going to call this, so S of 1 is 1. Right? When you put 1 in here, you get 2 times 1 over 2, which is 1. Now, your inductive case is assume this works for some k. Okay? Okay? We're going to assume that it works, that this is the answer for some k. Now, we're going to look at k plus 1. Okay? So we're going to look at
K plus 1.
Huh?
K plus
You know
1.
the sum of
K plus 2
k.
plus 1.
No.
Huh?
You don't know that yet.
What?
That k
We
plus
don't know this. We are trying to prove this.
Yeah.
So we are assuming this, and we have to prove this. So now we take this part of this and try and rearrange it so that it looks a little like this. So
You
we will
start
do-
from that side, no?
Huh?
K. Should I do?
Yeah.
Madhav, can you check if everybody knows that? Is it?
Can you move the center of the table? Center of the board?
Sideways. Huh? Oh, that's k by 2, is it? Yeah.
K plus 2 can be written as K plus 1 plus 1.
Yeah.
So K plus 1, if you rephrase it as x, then it becomes S of x is equal to x by 2 into x plus 1.
Okay, yeah. Okay.
You know that the sum of the first k integers is k by 2 into k plus 1. Okay, if I know that the sum of the first k integers is this much, how do I find the sum of the first k plus 1 integers? I add k plus 1, right? If I know that the sum of first 3 integers is 6, how do I find the sum of the first 4 integers? To the sum of 3 integers, I add the fourth integer. So the sum of sk plus 1 would be the sum of the first k integers, which is k by 2 into k plus 1. To this, I add another k plus 1. So now juggle with this, k plus 1 is out, k by 2 plus 1, that becomes
K plus
1, k plus 2, k plus,
make it k plus 1 plus 1.
k plus 2 by 2.
Ah.
You do that. That will be k plus 1 by 2.
Which is
Which is what you would expect.
So what you proved is that given sk plus 1 works, and you proved the base case that S1 works. So therefore, if S1 works, by the inductive case, S2 has to work. And if S2 works, then S3 has to work, and so on and so forth.
This is called
Mathematical. Yeah. Yeah.
See, we use this in that region wala proof.
Yeah.
This was the kind of argument that we used.
But it wasn't explicitly shown
It
to
wasn't
the induction,
explicitly mentioned.
So you mean to say sk plus 3 will be equal to k plus 2 upon 2 plus, in brackets k plus 3?
sk plus?
sk plus 3 is equal to sk plus 2 upon 2.
K plus 3.
K plus 3 is equal to. Okay.
You can give you a domino system. The other day you were saying that, right? Like if one falls, the other one falls.
Yeah, so the basic idea is the domino thing. One falls and then all go down.
Somebody was asking about the pendulum and the pendulum.